Enhanced Interior Gateway Routing Protocol, EIGRP, is a proprietary Cisco protocol, which replaced Interior Gateway Routing Protocol, IGRP. It is also an advanced distance vector routing protocol. However, some people call it a hybrid. It does not have a total view of the network as a link state protocol would. However, it maintains more information than RIP. EIGRP does not require a hierarchical addressing scheme, but it works better with it. It is the only routing protocol covered in this course that can support non-IP protocols. Protocol-dependent modules, PDMs, handle Novell IPX, AppleTalk, as well as IP. EIGRP allows route tags. It uses IP Protocol 88 for messaging. It does not use User Datagram Protocol, UDP, or Transmission Control Protocol, TCP. All the routing protocols except the BGP use their own protocol numbers. Convergence occurs very rapidly as a network needs to converge or settle down to normal operations after a change. For example, if a router interface fails, many events occur. The router, along with the neighbor or neighbors on the other side of the link, recognizes that there is a failure. They must recalculate the routes for their routing tables since any routes using that interface will no longer work. These are just some processes that occur after a change in topology. The time taken for these processes to complete is called convergence time. Let us now look at the algorithm to determine the best path. Diffusing Update Algorithm. All routing protocols use some type of algorithm to determine the best path to each destination. What is considered the best path depends on the metric used as well as the algorithm. The algorithm used in EIGRP is Diffusing Update Algorithm, DUAL, developed by Dijkstra. DUAL is run against the topology database to determine the best path and to rank backups for the path. DUAL finds loop-free routes. The Dual Finite State Machine, FSM, selects the best, least cost path to insert into the routing table. After routers boot and initialize, EIGRP DUAL is rerun only against those portions of the routing domain that are affected by a routing update. That is why it is said EIGRP updates are bounded. Let us look at other router mode commands. The Auto Summary setting is the default configuration for all iOS versions before 15. This means all routes are advertised as classful networks. Discontiguous networks and variable length subnet masks, VLSM, are not supported with this setting. Most often, as seen on the slide, no auto summary is configured. In fact, it is the default starting in iOS 15. For iOSs before this, forgetting to turn off auto summary is one of the common EIGRP routing problems. In the next slide, we will discuss Network Command. The Network Command determines the interfaces that would be enabled for EIGRP. An interface is EIGRP enabled if the address of that interface lies within the subnet defined in the command. Click the button to see the command. There are two options of entering the network command. The first option is to enter a classful subnet with no inverse mask. If you do not enter a wildcard mask, EIGRP will summarize the network to its classful boundary. Without an inverse mask, any interface that belongs to the classful network of the subnet configured will participate in EIGRP. For example, if you enter network 172.21.10.0, then EIGRP will interpret that as 172.21.0.0 with the default prefix length of /16. This classful treatment occurs independent of the auto summary setting. The second option is to enter a subnet with an inverse mask. An inverse mask is the regular subnet mask subtracted from 255.255.255.255. For example, The inverse mask of 255.255.240.0 is 0.0.15.255. The inverse mask is configured same as a wildcard in EIGRP and ACLs. If you configure an optional inverse mask, any interface belonging to the configured subnet will participate in EIGRP. Click each command on the screen to learn more. To advertise the default network, use the network 0.0.0.0 command. To verify which interfaces have been enabled for EIGRP, use the Show IP EIGRP Interfaces command. Let us look at the router ID in the next slide. A router ID is in the form of an IPv4 address or an integer. It can be configured manually with the EIGRP router ID command. It is to be noted that there is no IP before it, unlike the majority of other EIGRP commands. Click the button to see the command. If a router ID is not configured, the router automatically chooses one. If there is an active loopback interface, it chooses the highest IP address on an active loopback interface. Otherwise, it chooses the highest IP address on an active physical interface. We will continue our discussion on router ID in the next slide. Duplicate router IDs do not prevent routers from becoming neighbors. However, this becomes a problem in redistribution, where the router ID becomes part of the routing information. In contrast, duplicate router IDs prevent routers from becoming neighbors in OSPF. To verify router ID, use one of the following commands. Click each button to see the commands. Click the Next button. Click the Next button. Now, let us look into EIGRP metric weights in the next slide.